So our last thing here we're going to talk about is going to be about percent error. Now, error is basically how far off you are from reality whenever you measure something. Oftentimes is that you may measure something and you know that, say, that the Fahrenheit, the freezing point of water, should be at 32. Now, let's say that you do a measurement, you stick a thermometer in water and you watch it cool down until it starts freezing, it shows ice crystals, and it says the temperature was 35 when that happened. You were off by 3 degrees. There's some error. There are two types of error. There is absolute error and there is relative error. Absolute error would be, in that case, the fact that you were off by 3 degrees. It tells you exactly how much you're off based on sort of the amount that's that you're off by. Just measure the difference. The problem with absolute error is it really doesn't tell you how good your result is. Like, let's suppose that I measure something, and when I measure it, I am off by 10 inches. Okay, so you know the absolute error. It's 10 inches for this length that I've measured. But the question is that a good value or is that a bad value? Did I do a good job of measuring or a bad job of measuring? If I was, say, measuring the distance between the Earth and the Moon, and I was off by 10 inches, I'd say that's a pretty good measurement. That's really, really good. Now, on the other hand, if I was measuring my height and I was off by 10 inches, then that's a really, really bad measurement. I did a really bad job of measuring if I'm off by 10 inches on a person's height. So what we really need is we need a relative error, an amount where we compare the amount we're off by the total amount. And the way we figure out a relative error is by using the percent error formula, and that's the one you have on your screen right now. Percent error is basically equal to, the first part of it here is, this is absolute value, so we see our little absolute value signs on both sides here. So absolute value of the actual value, what it really is, so this is sort of what it really is, minus the measured, which is what you measured, divided by the actual. Now, because of the fact we have an absolute value on the top, that means that that difference is always going to be positive. It's always the positive difference between what it really is and what you measured. And so you take that positive difference, you divide it by the actual value, and then you multiply it by 100, and that's what gets it into percent here, is do that. You need to be careful. Sometimes you'll see this is written with 100% on the end. The only problem with doing that is that's fine. That's actually more accurate. You have to be careful because a lot of times when people want to multiply times 100%, they say, well, 100% is 1, so let's multiply by 1. You do want to multiply by actually 100 here, which is why I didn't put in the percent sign there. But you basically take percent error, you take what it really is, you take the difference between that and what you measured, find the positive difference between those, divide it by the actual value, and then that's what you've got right there. So that's how you figure that out. Let's try working out a quick example on this. A couple examples. And go from there. So let's find the percent error for the following. A rug with an area of 110.4 square feet is measured to be 8 feet by 14. So what we want to end up doing here is, first thing, what is our actual? Well, actual, it says it has an area of 110.4 square feet. That's what it actually is. And it's measured to be 8 feet by 14. Well, if it's measured to be those, we could use that to find what our measured area is. And so our measured area would be simply 8 times 14, and these are both feet. So that's feet, a little feet sign up there. And so we multiply 8 times 14. And so if you put that in your calculator, or if you know it off the top of your head, we say 8 times 14 is equal to 112. So we get 112 square feet. All right. Well, to find percent error, what is it? The percent error is going to be actual value, it's absolute value of the actual, which we said was 110.4 minus, put that in parentheses so you can tell what it is, minus the measured value, which is 112, like that, divided by the actual, 110.4, and then we'll take that times 100. So times 100, put that over there. So doing this, what's the difference between, what is 110 minus 110.4 minus 112? So we say 110.4 minus 112. And if you do that in your calculator, you get negative 1.6. But because of the fact that this is absolute value, this becomes positive 1.6. So you get just 1.6 divided by 110.4 and then times 100. And so doing this right here, you say that what we have here is we have 1.6 divided by 110.4, 110.4, and then you take that number and multiply times 100. And if you do that math, you get that we have a final percent error here of 1.449%. Now notice that we didn't worry about significant figures there. Taking a look at our original numbers here is that usually what you want to do is that whenever you're figuring significant figures is that don't ever do any rounding until you get to the final result. And so, you know, we could have gone ahead and we said we could have rounded this number right here, this 112, but we don't want to do that because we're not to the end yet. What you want to do is you then want to go back and take a look and say, well, this should only have, the 112 should only have one significant figure because of the 8. And so that means that these two, this 112, would actually be rounded to the hundreds place. And so that means that our top answer will only have one significant figure. So that means that we have 1 divided by something that has 4 significant figures. That's going to end up giving us a total of 1 significant figure. So our final answer would actually just be 1% because it only has 1 significant figure there. So, so that's something to keep in mind. Let's try our next one. Pi is measured to be 3.3. And so, well, this one should be a little easier to work out here. So our percent error is equal to the absolute value of the actual, which is 3.14, and you can look this up if you want to, 1592654 if you want to keep going, but we really don't need to go that far. That's our actual minus our measured, 3.3, divided by the actual, 3.14159 times 100%. And so doing this guy right here, and let's put a little dividing line so we can see which ones are which, like that. So multiplying that out, we say first 3.14159 minus 3.3, and so we say minus 3.3, and so doing that, we get a total of 0.15841, if you're doing it in your calculator, 0.15841, divided by the number on bottom, which is pi again, 3.14159, and then multiply that times 100, and so when you do that, that you should end up getting a total of 5.04, which, because of the fact our original number here had 2 significant figures, our final one's going to end up with 2 significant figures, and so we have 5.0% error is what we get on that. So that right there is how you go about finding percent error. Relatively straightforward if you know what you're doing, but that's basically how we set this up. So that concludes what we have for today's lesson.